So up until this point of algebra, we have been able to solve equations like this first one, 3 to the 2.5. You might not be able to do this on your own, but you do know how to use a calculator to raise 3 to the 2.5 power. And if you do that, you get roughly 15.6, somewhere around there. And over here, if you have x squared equals 10, we have seen how to solve for x. You would take just the square root of both sides, because the square and the square root would cancel out. You get x equals whatever the square root of 10 is, which you could find with a calculator. But over here, how would we find out what x needs to be in order to be 3 to that power equals 15? This is something we haven't learned how to do yet. And this is really the basis of coming up with some sort of a function that inverts this whole operation in order to find out what x is. And this is where we're going to use what's called a logarithm. A logarithm is basically saying this. If I have a function like b to the x equals y, I can rewrite this function as a logarithm. So we know that a logarithm with base b of y is equal to x. This is the basic foundation for what we are going to do with logarithms. This is a very important thing to remember. Let's look at a few examples where we can see how to switch between these two forms. And before we jump right in, there are a couple special examples of this logarithm that we need to just make sure we have out there. If you look on your calculator, you may see a button that looks something like this, and it just says log on it. Well, when you type that into your calculator, it gives you an option to do log of some number, but it may not allow you to enter the base in just on that shortcut key you have on the front of your calculator. The reason why is it is assuming you are talking about a log base 10. Log base 10 is often referred to as the common logarithm. And there's another button on your calculator you may realize, and it's usually right next to the log button, and it's the ln button. If you find that, you may be tempted to touch it, and if you do, you'll see that it will enter in ln, and then you'll have an empty spot to put in a number here. And the reason why it's not asking you for a base again here is because the base of ln, which is called the natural logarithm, this is usually referred to as the natural logarithm, is because ln is actually referring to log base e of some number. So these are two very important things that we need to realize. Let's go ahead and let's just put them on the screen off to the side to keep in mind while we look at our examples. Log base 10 of x, again, that's just referred to as log of x. So if you don't see a base, assume it's a 10 because that is the common logarithm. And then again, log base e of x is referred to as ln of x. Now, if you don't know what this number e is, consider checking out the video that I posted on what the number e is. I'll go ahead and put it in the top right corner right now. Might be worth a look. So if I have 3 raised to the second power is equal to, well, if you know your math, you might realize that that's equal to 9. I'm just going to write it like this. So what I want to do is I want to convert this into logarithmic form because it's already in exponential form. So I'm starting with b to the x equals y, and I want to convert it into log base b of y equals x. When I start in my base, what happens with my base in logarithmic form? Well, it always goes to the base of the logarithm also. So when I write my log base, it's going to be converted into log base, and then it's going to be 3. And then my y, which is the number that it's all equal to, is ultimately the number that goes in right here. So I can say log base 3 of 9 is equal to, and there's only one number left, but just so we're clear, the number that is the exponent is always what the logarithm is going to be equal to. So it's going to be equal to 2. So in other words, what this is saying is 3 raised to what power is 9? Well, 3 raised to what is 9 is ultimately 2 is going to be my answer. 3 raised to the second power is equal to 9. That's what a logarithm is basically telling us here. Now let's say I have a function in logarithm form. And let's say it's log base 4. And we're going to say it's log base 4 of 1 over 4 equals -1. And you could look up what is log base 4 of 1 over 4. You would find that it's equal to -1. Now, let's write this in exponential form. Now, let's reverse this process from before. My base down here, the 4, is going to be the base of my exponent. So 4, and now we're wondering what power do we need to raise 4 to get 1 over 4. The answer that my logarithm gives me is ultimately the exponent that I have to raise my base to. So if my logarithm is equal to -1, that means it is going to be 4 to the -1 power. And then that is equal to whatever the input of my log function is, which in this case is 1/4. So it's just 1/4. And we can ask ourselves, does 4 to the -1 power equal 1 over 4? Yeah, it does. We could check that. So that's a couple examples. Now let's look at a couple more with a bit of a clean slate. So here I have 2 more expressions. And I just went ahead in my calculator and did e to the second power. And what I got out was 7.389. Now, if I want to write this in logarithmic form, all I have to do is make sure whatever the base of my exponent was is the base of my logarithm. So it's log base, whatever it is, which is e. And then the exponent is always what my logarithm is equal to. So log base e of something is equal to 2. And that something is this number right here. So it's going to be log base e of 7.389 is equal to 2. Now, if you remember from before, log base e goes by a special name. It's called the natural logarithm. So instead of writing it as log base e, I'm going to write it as ln of that number. So let's go ahead and replace it. Now I can say instead of log base e of 7.389, I can just write it as ln of 7.389. And that's equal to 2. And you could check this. You could find that natural log button on your calculator, hit ln, type in 7.389, hit equals, and you will get a 2 as your answer. And then down here we have log of 3 equals 0.477. Now, how do I write this in exponential form? If you're picking up on the pattern, the base of the logarithm is going to be the base of the exponent. Well, there is no base here. What in the world is going on here, right? If you remember from before, let's look at this. We have log base 10 is called the common logarithm, and so we can just shorthand it by saying log of x rather than log base 10 of x. So here, this doesn't mean there's no base. It means that my base is log base 10 of 3. Is equal to 0.477. And so now I can write this in exponential form by saying the base of my logarithm, again, is the base of my exponent. So it's 10 raised to what my logarithm equals, which is 0.477. And that's equal to ultimately 3, according to this logarithm. And if you type into your calculator 10 to the 0.477 power, you will get 3 as your answer.